if we are thinking of a weaning age of 3 to 4 weeks, and we know that to develop immunological memory and protection against that virus, it takes a few weeks. How shall we do that? So the immunologist in me tells me, leave the piglets longer with your sows, and if you give the vaccine developers or the vaccine time, let's say 6 to 8 weeks for that purpose, just to protect the pigs, then yes, we would have a lot more success in preventing it. Now, if you talk to the swine producer, they will say that's not possible, right? Mm-hmm. It's just too big of a sacrifice money-wise that we actually give them that much time. And I think that is our biggest issue, that at weaning, we create a situation where the pig is extremely stressed. It's then also very, very prone to become infected with viruses or bacteria. And with that commingling, we additionally put a lot of pathogenic pressure on these pigs, which are already suffering, which are already stressed, and they don't have a functional immune response. And at that point, then also maternal immunity will be waning, it will decrease. So we have now that window where we have a really vulnerable weaner with a lot of pathogens coming into that exactly at the stage where we, at that point, cannot induce very strong immunity in the pig yet. So I think that's basically a problem that vaccinologists on their own cannot solve because we just don't have enough time.
Swine it. Well, good morning, listeners, or I should say good afternoon to our guest. I'm excited. Dr. Tobias Keser is joining us today. He's an assistant professor in immunology at the University of Veterinary Medicine in Vienna, Austria. Toby, how are you doing today?
All good, all good. Thank you for having me.
Yes, welcome. So first, what do you want your listeners to know about you? Go ahead and introduce yourself for us.
Oh, okay. To know about me, I'm a biologist. I studied in Germany, molecular biology, virology, and microbiology. And then on a weird path, I started about working in swine immunology. I focused on the T-cell response and the adaptive immune response in pigs. And I did that in Vienna already. About 20 years ago now, from 2004 to 2013. And in 2013, I then joined VIDO, so the Vaccine Infectious Disease Organization in Saskatoon. I worked there with Dr. François Morin and Volker Gertz, and we established swine as a biomedical animal model for research on Chlamydia trachomatis, so the sexually transmitted disease, with a future goal to develop vaccines against it. And from 2013, sorry, 1 second. No, I lost track already. No, from 2016 actually to 2022, I then joined NC State, the College of Veterinary Medicine there, and was an assistant professor in swine immunology there. And there we continued with the Chlamydia project. So we established a pig to develop vaccines against Chlamydia. We studied food allergy, and we worked a lot in PRRS, what our swine community knows quite well. And since 2023, I am back here in Vienna, where also the family of my wife is, and lots of friends. And we continue with the Chlamydia research and see what else we can help with, probably also PRRS.
Yeah.
That's basically awesome. Me.
Evonik Animal Nutrition is committed to ensure food security and safety while reducing the ecological footprint of animal farming. Its products and services use evidence-based solutions that seek to promote animal welfare and reduce reliance on natural resources. All this is underpinned by long-standing industry partnerships and deep customer understanding. Evonik's focus on efficiency, sustainable, healthy nutrition, and collaborations with livestock farming partners creates value for customers and consumers.
Well, let's start there, Toby. Thanks for that introduction. Let's start big picture, right? As you know, stateside, in your past experience and in your current experience, right? And it feels like our battle against PRRS has been ineffective. But we have learned some things. And specifically, what have you learned throughout your research and your work on how we can better fight PRRS and how we can throw up better defenses against it?
Oh, that's a tough question. If someone really solved that, I wouldn't be sitting here. But as you said, yeah, we've learned a lot, and we still don't know exactly how to control it. And I think you're asking an immunologist here. And the immunologist, as an immunologist, I see the issue of timing a lot. So we know that the immune response in pigs at early ages it's just not as strong as if you have a healthy adult pig. And if you vaccinate this adult pig, you will get a really pronounced immune response. And if you, for example, use a modified live virus vaccine, we also know that it can be heterologous. So we can create an immune response against different strains of PRRS. But in a young pig, this is extremely difficult. And especially if you think of how pigs are raised, we run into the challenge of creating heterologous immunity against an immunosuppressive virus at a very, very early stage. So if we are thinking of a weaning age of 3 to 4 weeks, and we know that to develop immunological memory and protection against that virus, it takes a few weeks. How shall we do that? So the immunologist in me tells me, leave the piglets longer with your sows. And if you give the vaccine developers or the vaccine time, let's say 6 to 8 weeks for that purpose, just to protect the pigs, then yes, we would have a lot more success in preventing it. Now, if you talk to the swine producer, they will say that's not possible, right?
Mm-hmm.
It's just too big of a sacrifice money-wise that we actually give them that much time. And I think that is our biggest issue, that at weaning, we create a situation where the pig is extremely stressed. It's then also very, very prone to become infected with viruses or bacteria. And with that commingling, we additionally put a lot of pathogenic pressure on these pigs, which are already suffering, which are already stressed, and they don't have a functional immune response. And at that point, then also maternal immunity will be waning, it will decrease. So we have now that window where we have a really vulnerable weaner with a lot of pathogens coming into that exactly at the stage where we, at that point, cannot induce very strong immunity in the pig yet. So I think that's basically a problem that vaccinologists on their own cannot solve, because we just don't have enough time. But I do understand the pig producers on the other side as well, that they cannot say, hey, just because your vaccine is not working, now we're gonna raise our pigs very differently and give them wean with 6 weeks of age. Not gonna happen, right? So I think that is the biggest issue. It's timing and the time of the immune response, how long it takes to develop actually immunity against a virus like PRRS.
Sure. So do you think that we'd be more effective in terms of bolstering the immunity? And one term that you use that I really like is, immunological memory, right? In terms of bolstering the immunity within our, gilt development and our sow herds to better protect those progeny. And how successful do you think, that strategy has been? Because, there are cons to that, right? And we've seen that in terms of, vaccination, basically going rogue and basically becoming a wild type PRRS within systems, right? So kind of explain the pros and cons from your perspective as a scientist, Toby, on how those programs can be effective or ineffective.
Boosting maternal immunity is generally a good thing, especially if you want to protect your nursery pigs, obviously. So we do know that it can be beneficial, and we've done a study where we combine modified live virus vaccines with autogenous and activated vaccines, and that actually boosted the protection quite well, specifically through the transfer of neutralizing antibodies. So I think it is a good strategy to provide maternal immunity and have a really effective vaccination of the sows. On the other side, you also raised the issue that modified live virus vaccines can become problematic as well. And this is true, right? We've seen it that some modified live virus vaccines are really hard to eradicate. And we see that if they are actually in the system, pigs don't grow as well and cause also issues which are sometimes less, sometimes more, let's say. And optimally, we would have a non-modified live virus vaccine, which is as protective as a modified live virus vaccine. The issue is we don't have that yet. So what we've seen is that we can induce strong immunological memory with good vaccines. And we've also seen that, for example, during COVID, at the beginning, we had a bunch of different systems that actually went into that pipeline. We said, okay, we are using now modified live virus vaccines, killed vaccines, and then mRNA vaccines came along. And if you follow that process down the road, what ended up being very successful were actually these mRNA vaccines, which is a new technology, and it's not available yet for us because it's just too expensive actually to produce mRNA vaccines for pigs. It's just the cost will be too high. But what we see is that further down the road, there is a technology, there are different technologies that we can improve non-modified live vaccines to become really immunogenic, then hopefully also protective against a virus like PRRS. So I wouldn't give up hope yet, but until we actually have that optimal vaccine against PRRS, it's a tough choice. And I think there is no right answer. So I think it depends really on your problematic, how much cost do you have caused by PRRS, and I'm not a swine producer, so I think asking the vets out there, they will make the right decision, and they know much better if they want to implement an MLV vaccination program or not. So there is no right answer. As I said, this is a balance of what is most cost effective.
Yeah, no, I appreciate that answer and that thought, Toby. One thing that I get asked from time to time, right, as a scientist and someone that's not an immunologist, right, is to what's the difference between an mRNA vaccine and a modified live vaccine, and what's the technology around it, and how does the pig, or in this case, right, with COVID, right, the human respond to those vaccines differently? So you provide a little bit of a breakdown of those different vaccines that are employed, and what makes an mRNA vaccine different and maybe more effective than a modified live vaccine.
Okay, well, that could go hours and hours.
Right. So if you try to give us the 4-minute high-level version, Toby.
A very high-level version. So a modified live virus vaccine mimics a virus infection, right? If we're talking about viruses, what we do here. Then you have that virus infection. It's very immunogenic because it's just you have all the immunological triggers that you need to really stimulate the immune response. Now, obviously, it has a huge downside because it's a live virus, or not because viruses are not live, but it's a non-replication. So replication, like a live virus, if you're taking it in the non-scientific term. And then you have, for example, mRNA vaccines, which are also extremely immunogenic, and they are very flexible in how you can design them. So you have now the advantage that the mRNA vaccines are nearly as effective as a modified live virus, but without the downside that it's really infectious. So an mRNA vaccine is already also, it's providing the innate stimuli that you can already activate the early phases of an immune response, and it is producing a lot of that protein that you have in there, or what the mRNA is encoding for, and it's directly delivered very nicely. So you have a lot of the stimuli for the innate as well as for the adaptive immune system. So that's why they are so strong. And since you basically have only a lipid membrane with an mRNA in it, you can just simply swap the sequence of that mRNA, and that makes it very powerful because you can adapt it very quickly to different strains, which would be also highly advantageous for PRRS vaccines.
Yeah. Thank you for that insight, Toby. A little bit of a pivot. One area of your research that you've done in the past and currently is use the pig as a biological model for food allergy and vaccine development. You just kind of start big picture and highlight some of your work and findings from that area of research.
So we've used it on the one side to develop vaccines against chlamydia, and then also in food allergy. So if we start with the chlamydia project, we've seen that basically every pig of 7 weeks of age has chlamydia, which not a lot of people know.
Yeah, I did not know that.
So that's Chlamydia suis, which is the pig pathogen, and it's basically in every pig in North Carolina, but it was, also not only North Carolina, all over the US, and you find it in Europe and all over the place. And it's mainly actually a gastrointestinal bacterium, which is not causing a lot of issues, and it's only if it's actually then transmitted to the genital tract where it can cause issues also for the pig production. And we've used that as a model to develop a vaccine against Chlamydia trachomatis. The big advantage of using pigs is here that on the one side we can infect pigs with a human pathogen of chlamydia, so the Chlamydia trachomatis, they are susceptible to it and they respond with the same immune response against it. What we've also learned is that the immune response of the pig against Chlamydia suis is actually also recognizing Chlamydia trachomatis. So if we now use chlamydia pre-exposed, so for Chlamydia suis pre-exposed pigs, to develop a vaccine against Chlamydia trachomatis, we have one big advantage. On the one side, or two big advantages. On the one side, the pig is outbred, which is also means it is genetically diverse, just as humans, which is a big advantage over mice. And on the other side, with the cross-reactivity of Chlamydia suis to Chlamydia trachomatis, we now actually have a model that mimics the clinical phases, where you usually use for sexually transmitted diseases, you use high-risk patients, which have previously been pre-exposed to Chlamydia trachomatis in that case. So now we have basically the same cohort of individuals that we are using in our vaccine development phases as later as in the clinical trial. So we hope that with the outbred population, with the pre-exposure, and also with the similarities, general similarities between pigs and humans, that we have a high chance that the results that we generate in pigs are actually translating to humans. And if we develop now a protective vaccine against chlamydia in pigs, that this will also be then successful in humans. So I think that with that, the pig is really predestined to be used as a vaccine development animal model for chlamydia. And for the food allergy project, it was actually started by a colleague of mine, and they actually found that they can induce food allergy in pigs using a sensitization and an oral challenge model, and that the pig is mimicking also a lot of these immune responses that are developing in food allergy in humans. And also, so what we've looked at is esophageal eosinophilic esophagitis. It's an allergy in the esophagus, and also if you look physiology-wise, the pig is very close. So the pig esophagus is very closely related to the human esophagus. So once more, we have just a similar size, similar physiology, similar immune system, and now with the developed sensitization and oral challenge protocol, we can now actually induce that food allergy in pigs, and now have a good model that we hopefully can use it for translation and research to develop new methodologies to treat these diseases.
Yeah, no, thanks for sharing that. So the other part we've been highlighting, your research, your past findings, and your insight, right? The other part about your role is producing the future wave of scientists. So kind of explain your role currently, Toby, at the University of Veterinary Medicine in Vienna, Austria, and how you support the next generation of scientists and veterinarians.
So my role here is, as it was in North Carolina, it is, let's say 1/3 is teaching and 2/3 is research, but also during the research, we actually try to promote, creating the next veterinary researchers and also veterinarians. So my role here, what I would highlight is that I try to, on the one side, collaborate a lot with, on the one side with the industry, but also with clinicians. So that has been shown to be very successful in the US, and I want to continue in that matter, in that we both basically in all my projects, we never did that on our own. So we always worked for PRRS. We worked with the swine industry, with the vaccine industry. So, and you get so much insight from really good swine veterinarians, Jeremy Pittman, for example, or if you work with the vaccine industry, we work with a lot with Elanco, Mark Hammer, and these discussions were just like, these are the problems we have. And if you then have someone who's talking both languages, this is really great. And so this is what helps us doing good research. And if you then incorporate really talented and motivated students, then this is already going by itself. So you don't have to do much then. You just have to provide them with good projects and then some mentoring that they do the work. Our last review, for example, on the immune correlates of protection in PRRS, that was all done by Andrew Kick. So he was driving that. This was his thing. You just give them the space to grow, and they will do that on their own. So I think that is what a mentor should do. Not you need to do this A, B, C, and D, but rather really provide them with the space that they can grow and learn on their own.
Yes, yeah, you have to provide the runway where they can fail just a little bit, because oftentimes,
exactly.
Right, we learn more from our failures than we do from our successes, right? So, yeah, no,
an
that's
expert
awesome.
Is someone who has done the most mistakes in one specific area.
Yeah.
We have a time and labor-saving product for you. AgriSlats by Healthy Farms is your solution. No more lugging jugs around the barn every month. With AgriSlats, you simply drop the slat through the floor twice a year, and it works to break down solids, reduces crusting and forming. To learn more, visit myhealthyfarms.com.
Well, I have kind of 4 fun questions to end on here for us, Toby. The first is, what's your favorite thing to do in Vienna in the fall?
Going outside to the Danube, Donaupark, the park of the Danube, I think. With my 2 little kids, and that is just fun. I've done that yesterday evening. It was, spontaneous, and this is just great. Just hanging out there, having a picnic, and they are running around. It's nice.
Yeah, that's awesome. What's the biggest hurdle that you've overcome that you're the most proud of?
I honestly don't know of a single specific thing. It's rather a I think rather a mindset that my mantra is, it always works out somehow.
Mm.
And I generally look at the solutions and not so much at the issues. And I think this is it's rather the mindset, and in general that it's working out somehow. Don't fret too much about it. I think I've learned that over my lifetime, and learning that is, I think, what I'm basically most proud of. That it always works out somehow.
Yes, yeah, it always does. What's your favorite pork recipe?
My favorite, it's a pork roast. It's actually in I think, an Austrian way to do it. So you have the whole shoulder with the fat on top, and then you cut it open. So you cut the fat and then you put it in the oven as a whole, and then you just slice it. It's delicious.
Oh, that sounds amazing. Especially as we come into the fall, right?
Yes, exactly.
All right, so my last question here, Toby, for you is, if you could solve one of your research questions that you have currently tomorrow, which would you pick?
Which one would I pick? I think it's the food allergy. Having no food allergy. I know I'm working on chlamydia. This is my top project right now. But I think having no food allergy, seeing what food allergy, how it can impact people's life, is just no food allergy anymore. Out of the three, I would pick that one.
Yeah, no, completely agree. That's a great one. Even just as a pork producer, right? With the tick-borne illness, that we have, fighting, red meat consumption, right? Just a solution around that would be awesome, right? And just the ability to help feed and nutrition the world. If there were less barriers about, what people can consume versus can't consume due to, health implications, man, that makes that question just a little bit easier to answer for us, doesn't it? So,
yeah, exactly.
Well, Toby, I want to really thank you for your time today. This was enlightening. I'm sure our listeners got a lot out of it, because I know I did. For our listeners, I hope you tune in to future episodes of the Swine It podcast, and I wish you a great day.